kagang akipabama, kagang akipabama, sinasukat kam Lampung. Lestarikan budaya, lestarikan budaya, hamjaja mangajunjung. Lestarikan budaya, wilawi wahilawi, lestarikan budaya, hamjaja mangajunjung. Bandak Lampung, Ukida bandar Lampung, kota tapis berseri. Hasil bumi ini ngagung, hasil bumi ini ngagung, pahila dare kupi. Hasil bumi ini ngagung, hasil bumi ini ngagung, hasil bumi ini ngagung, pahila dare kupi.
Occasion YC 2024.
Lampung, Lampung kota wisata, Lampung kota wisata, wai kembas ni budiri.
We would like to welcome Rektor Universitas Islam Negeri Raden Intan Lampung, Profesor Konstantinus Ravanis from University of Patras, Greece, Dr. Elizabeth Edward from the University of Queensland, Australia, Dr. Vishal from Art and Science College, Sakarkeda, India, Fajrul SSSEE MSc from Akademi Inovasi Indonesia, Dr. Achi MSc from UIN Raden Intan Lampung. Tapis Lampung is being handed out for the distinguished guests. It is the traditional cloth from Lampung which is given as the symbol of warm welcome. Welcome to Lampung Province in YC 2024. His Excellency Rector and the guests, would you please to have a seat? Thank you very much and welcome to YC 2024. Ladies and gentlemen, please have a seat. Ladies and gentlemen, please enjoy Sekapur Siri Dance. Ladies and gentlemen, Sekapur City Dance is the symbol of happiness due to the special guests come to Lampung. It is also as the gratitude of attending in Lampung. Raden Intan Lampung and the respectable guests, here is the giving better leaves to the distinguished guests as the warm regard from Lampung Province Society. Applause to Sekapur Siri Dance. In an enthusiastic atmosphere, we proudly present the 7th YC International Conference 2024. The Young Scholar Symposium on Science Education and Environment, or YC 2024, is an annual symposium hosted by Universitas Islam Negeri Raden Intan Lampung, Indonesia. YC offers opportunities for educators and researchers to share their ideas and research findings in the natural sciences, environmental science, and science education, encompassing physics, mathematics, biology, and chemistry education. The journey began with the first symposium known as the Young Scholar Symposium on Transdisciplinary in Education and Environment, or YSSSEE, held in 2018 at MRC Hotel Bandar Lampung. The YSSSEE 2018 manuscript has been published in JPCS IOP Volume 1155 Issue 1. Subsequently, the second symposium, Young Scholar Symposium on Science Education and Environment 2019, or YC 2019, took place in 2019 at Novotel Hotel Lampung. The YC 2019 manuscript has been published in JPCS IOP Volume 1467 Issue 1. The third symposium, Young Scholar Symposium on Science Education and Environment 2020, or YC 2020, was conducted online in 2020 via Zoom. The YC 2020 manuscript has been published in JPCS IOP Volume 1796 Issue 1. Not to be missed, the fourth symposium, Young Scholar Symposium on Science Education and Environment 2021, or YC 2021, was held in 2021 via Zoom. The YC 2021 manuscript has been published in the AIP Conference Series, Volume 2595 Issue 1. The fifth symposium, Young Scholar Symposium on Science Education and Environment 2022, or YC 2022, took place in 2022 at Novotel Hotel Lampung. The YC 2022 manuscript has been published
in the AIP Conference Series Volume 3058 Issue 1. The 6th Symposium, Young Scholar Symposium on Science Education and Environment 2023, or YC 2023, took place in 2023 at Sheraton Hotel Lampung. The YC 2023 manuscript is currently in the process of being published in the AIP Conference Series. And now, the time has come for YC 2024. Many scientists and educators from all around the world will gather and discuss their latest research. Are you ready to join us?
Give applause to YC 2024. Assalamualaikum warahmatullahi wabarakatuh. The greetings from Lampung. Tabik pun. The Excellency Rektor Universitas Islam Negeri Raden Intan Lampung, Bapak Profesor Wan Jamaluddin Z MAG PhD. Vice Rectors UIN Raden Intan Lampung, Deans UIN Raden Intan Lampung, Head and Secretary of Research and Community Service, Head of Quality Assurance, Head of Internal Monitoring Unit, Head of Senate, Head of Community Service Center, Head of Research Center, Head of Halal Center, Head of Language Center, Head of Gender and Children Center Study, Head of Religious Moderation Center, Head of Community Health Service Center, the professors, the honorable keynote speakers, Professor Konstantinus Ravanis from University of Patras, Greece, Dr. Elizabeth Edward from the University of Queensland, Australia, Dr. Vishal from Art and Science College, Sakarkeda, India, Fajrul Falah SSE MSc from Akademi Inovasi Indonesia, Dr. Achi MSc from UIN Raden Intan Lampung, the invited speakers, and all the participants. Welcome to Young Scholar Symposium on Science Education and Environment YC 2024. Let's start our agenda by saying Basmalah. Bismillahirrahmanirrahim. Ladies and gentlemen, it is such an honorable for me, Mia Selvina, to be here as a Master of Ceremony for the 7th YC, the annual symposium held by Universitas Islam Negeri Raden Intan Lampung. Singing our national anthem. Ladies and gentlemen, would you please to stand up? Mars UIN Raden Intan Lampung.
Universitas Islam Negeri Raden Intan, aku pandang surah pedoman kita, kuatkan jiwa Islam yang kafah, tunjuk Islam sebagai rahmatan lil alamin, citra kampus kebanggaan menjadi yang terdepan. Tubuhin Raden Intan, universitas kebanggaan kita, wujudkan karya yang nyata menuju negeri adil sejahtera.
Ladies and gentlemen, please be seated. It's time for us to pray, which will be led by Mr. Muhammad Yasin Al-Arif SH MH.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Allahumma shalli ala sayyidina Muhammadin fil awwalin wal akhirin wa barik wassalim an sadatina ashabi Rasulillahi ajma'in. Hamdan syakirin, hamdan na'imin, hamdan yuwafi ni'amu wa yukafi'u majidah. Ya Rabbana lakal hamdu wa lakal syukru kama yanbaghi li jalalika wajhikal karimi wa adimi sultanik. Allahumma ighfir lana dhunubana wa li walidina warhamhuma kama rabbayana shighara wa li jami'il muslimin wal muslimat wal mu'minin wal mu'minati al ahya'i minhum wal amwat. Allahumma la tad'alana dhanban illa ghafartah wa la hamman illa farajtah wa la maridan illa sawaitah wa la aiban illa satartah wala hajatan min hawaiji dunya ila qadaita bi rahmatika ya arhamar rahimin. Allahumma ya musahil sahil, ya mudabbir dabbir, ya muyassir yasir, yassir lana kulla asir. Allahumma ja'al jam'ana hadzal jam'an marhuma wa tafarraqana min ba'dihi tafarraqan ma'suma. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar bi fadlika rabbika rabbil izzati amma yasifun. Wassalamun alal mursalin walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
As the warm greeting from committee, we would like to invite the Executive Chairman of Committee YC 2024 to deliver the speech. To the Honorable Bapak Profesor Dr. Kumedi Ja'far SHMH, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin wa bihi nasta'inu ala umurid dunya waddin. Assalatu wassalamu ala asrafil anbiya'i wal mursalin sayyidina wa maulana Muhammadin wa ala alihi wa ashabihi wa man tabi'ahu bi ihsanin ila yaumiddin, amma ba'du. Your Excellency Profesor Kiai Haji Wan Jamaluddin ZMAG PhD, Rektor of Universitas Islam Negeri Raden Intan Lampung, Indonesia. Keynote Speaker Profesor Konstantinus Ravanis from University of Patras, Yunani. Dr. Elizabeth Edward from the University of Queensland, Australia. Dr. Vishal R. Panse from Arts and Science College, Saharheda, India. Dr. Achi Rinaldi, MSc from UIN Raden Intan, Lampung, Indonesia. Fajrul Falah, SSE, MSc from Akademi Inovasi Indonesia, Indonesia. Welcome to Lampung, our distinguished guests and participants of your scholar symposium on Science and Mathematics Education and Environment International Conference 2024. Tabi pun, it's in our praise to Allah Subhanahu wa Ta'ala, the most merciful and beneficent, for granting us mercy, health, and blessing, allowing us to gather for this international conference. Salawat and salam to our Prophet Muhammad sallallahu alaihi wasallam, peace be upon him and all this component. Ladies and gentlemen, in this solemn moment, I am pleased to report on the progress of our conference presented by Research and Community Development Center Universitas Islam Negeri Raden Intan, Lampung. This is an annual event that began in 2018, and now the YSSSEE International Conference held on July 30-31, 2024. Our special audience, we received an unexpected number of manuscript submissions for this event. By the submission deadline, we had received 110 manuscripts. However, after the peer review and revision process, the manuscript accepted amounted to 100 manuscripts. Ladies and gentlemen, the series YSSSEE International Conference activities began with a parallel session on July 30, 2024, and be continued by the international conference on July 31, 2024, starting at 9 a.m. to 5:30 p.m. Participants include final year students and academics from various domestic and international institutions, such as UIN Raden dan Lampung, Universitas Sultan Agung Tirtayasa, Universitas Pendidikan Indonesia, Universitas Lampung, Universitas Lambung Mangkurat, Universitas Islam Sultan Agung, UIN Kiai Haji Abdurrahman Wahid Pekalongan, Universitas Nurul Huda, Tokyo City University Jepang, Daffodil International University Bangladesh, Universitas Negeri Surabaya, Universitas Malikus Saleh Aceh, Poltekkes Kemenkes Tanjung Karang Lampung, Institut Teknologi Sumatera, Universitas Riau, Universitas 11 Maret Surakarta, and Universitas Negeri Jakarta. The manuscript presented at the YSSSEE International Conference 2024 will be published in a Scopus Index proceeding. Express my deep gratitude to all the committees for their
sincere help, support, and praise. I also thank everyone for their presence at the YSSSEE International Conference 2024. May Allah bless us and grant us success. Finally, I am Ahmad Humaydi Ja'far, the Executive Chairman of the YSSSEE International Conference 2024, and I apologize for any mistake. Thank you for your attention. Allahumma fiq ila aqwamit. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. And the next agenda, it's my deep pleasure to invite the Rector of Universitas Islam Negeri Raden Intan Lampung, Profesor Wan Jamaluddin ZMAG PhD, to deliver the speech and be the gong as the sign YSSSEE 2024 officially opened.
The Honorable today's keynote speakers, Professor Konstantinus Ravanis from University of Patras, Greece. As I have taught you that I remember when I visit the Rhodes Islands, near to the Greece, I think, it's very beautiful, very fantastic, and I still remember how it is very fruitful meeting held by UNESCO 13 years ago. Professor Dr. Anna Permanasari, MSc from Universitas Pakuan, Indonesia. Dr. Elizabeth Edwards from the University of Queensland, Australia. Nice to meet you too. Last year I have visited your university. It is very big, very beautiful. The greenest one, I think, in the Australia. Okay. Dr. Vishal, Advanced Arts and Science College, Saharkheda from India. Nice to meet you too. Welcome to Lampung. The highlight regard Mr. Dr. Achi Rinaldi MSI from Universitas Islam Negeri Raden Intan Lampung, Indonesia, and also my beloved guest here, Fajrul Falah, SSE MSJ from Akademi Inovasi Indonesia, and in high regard Professor Dr. Humaydi Ja'far SAG MH and Mr. Antomi, as a Chief of Research and Community Services Institute and the committee, organizing committee of this seminar. All participants, all attendants, Assalamualaikum warahmatullahi wabarakatuh. First of all, I give you the beautiful greeting, a special greeting from Lampung people. Tabi pun, Alhamdulillah, wassalatu wassalamu ala Rasulillah wa ba'du. Ladies and gentlemen, distinguished guests and esteemed young scholars, it is a great honor to welcome you all to the Young Scholar Symposium on Science Education, Earth and Environment 2024. This event marks a significant milestone in our collective efforts to advance science education and environmental stewardship for a global impact. Together, we will explore innovative solutions and share knowledge that can shape a sustainable future for our planet. We are privileged to have among us some of the brightest minds in the fields of science, education, and environmental research. This symposium provides a unique platform for young scholars to present their groundbreaking work, engage in meaningful discussion, and forge collaboration that transcend geographical boundaries. Let us seize this opportunity to inspire and be inspired, to learn and to teach, and to contribute toward the realization of more sustainable and equitable world. The theme of our symposium, Advancing Science Education and Environment for Global Impact, resonates deeply with the core objectives of sustainable development. Our commitment to integrating the Sustainable Development Goal (SDGs) into our academic and research pursuits is unwavering. By fostering a holistic approach to education, we aim to equip the next generation of leaders with the knowledge and skills necessary to tackle the pressing environmental challenges of our time. As we embark on this journey, let us remember that our efforts are not confined to the walls of academia. The initiatives we discuss and the partnership we forge here will have far-reaching implications for communities around the world. Let us strive to create an inclusive and dynamic learning environment that empowers individuals to become agents of change, driving progress toward a more sustainable future. Science education is crucial for several reasons. It prepares students for the future, fosters creativity, promotes critical thinking, enhances scientific literacy, and is important for the economy. By equipping students with necessary skills and knowledge, science education enables them to navigate a technologically driven world, encourage innovation, innovative problem solving, and contribute to economic growth through a skilled workforce in STEM fields. At UIN Raden Intan Lampung, our campus, we take pride in our commitment to environmental stewardship. Our initiative, such as label trash bin for waste sorting, the establishment of a greenhouse, and practice of a circular economy through a trash bank, exemplify our dedication to sustainable practices. Furthermore, our innovative approach to food waste optimization through the creation of eco-enzyme product showcases our ability to turn challenges into opportunities. These efforts have not gone unnoticed. In 2023, our campus UIN Raden Intan Lampung was recognized as the top Islamic campus in Indonesia for its green initiative, ranking names globally in the UI Green Metric World University Rankings. This achievement reflects our unwavering dedication to creating a sustainable and environmentally conscious campus that serves as a model for institutions worldwide. Our campus is more than just a place of learning. It is a living laboratory where theory meets practices, with facilities such as 11 artificial ponds, a bird conservation area, a greenhouse, an arboretum, a maggot house, and a compost center, we provide our students with hands-on experiences that enhance their understanding of environmental conservation. These living laboratories offer invaluable opportunities for research and innovation, enabling our students to develop practical solutions to real-world problems. Through this initiative, we aim to instill in our students a deep appreciation for the natural world and a sense of responsibility towards its preservation. By engaging in hands-on projects and research, they gain the skills and knowledge needed to become effective environmental stewards and leaders in their respective fields. Collaboration and partnership at the heart of our endeavors. We have established strong connection with esteemed institutions around the world, including Kirk University in Bangkok, Thailand, the University of Minho in Portugal, and Queensland University in Australia, among others. This partnership facilitates the exchange of ideas, resources, and expertise, enriching our academic and research programs, and broadening our global perspective. Through this collaboration, we are able to offer our students and faculty unique opportunities for international engagement and exposure. By working together with our global partners, we can tackle complex environmental issues more effectively and contribute to the creation of sustainable solutions that benefit communities worldwide. The Young Scholar Symposium on Science Education, Earth and Environment has come a long way since its inception. From its early beginning at the Young Scholar Symposium on Transdisciplinary in Education and Environment in 2018 to its current iteration, the symposium has grown in scope and impact. Each year, we have brought together scholars, researchers, and practitioners from around the world to share their insight and advancement in science education and environmental studies. As we look back on our journey, we are reminded of the significant contribution made by our participants and partners. The symposium has served as a catalyst for innovation and collaboration, driving progress in our shared mission to advance science, education, and environmental sustainability. We are excited to continue this journey with all of you and look forward to the new ideas and partnership that will emerge from this year's event. We are honored to have a distinguished line of speakers who will be sharing their expertise and insights with us over the next 2 days. Dr. Vishal from Arts and Science College, Saharkheda in India. Dr. Elizabeth Edwards from University of Queensland in Australia. Professor Konstantinos Ravanis from the University of Patras in Greece. Professor Dr. Anna Permanasari from Universitas Pakuan in Indonesia. Mr. Fajrul from Akademi Inovasi Indonesia are among the esteemed speakers who will be gracing this symposium. Their contribution will undoubtedly enrich our discussion and provide valuable perspectives of the latest developments in science education and environmental research. We are grateful for their participation and look forward to the knowledge and inspiration they will impart to us all. As we conclude this session, I would like to extend my heartfelt gratitude to all the organizers, speakers, participants, and sponsors who have made this symposium possible. Your dedication and hard work have ensured and success of this event, and your contribution will have a lasting impact on our efforts to advance science education and environmental sustainability. Let us carry forward the insights and the connection we have gained here and continue to work together toward a brighter and more sustainable future. Thank you for your attention, and I wish you all a productive and inspiring symposium. Finally, let's open this agenda together by reciting Al-Basmalah. Bismillahirrahmanirrahim. Thank you all. Wallahul muwaffiq ila aqwamit thoriq. Wassalamualaikum warahmatullahi wabarakatuh.
Rector UIN Raden Intan Lampung would like to open the ceremony by beating the gong.
Okay.
And we would like to invite to the stage all the Dean and Head of Research and Community Service together with Head of Senate to come in front to the stage to accompany Rector UIN Raden Intan Lampung to beat the gong as the sign that the annual event YSSSEE 2024 is officially opened. And please all the keynote speakers to come to the stage together with Rector UIN Raden Intan Lampung will be the gong as the sign that YSSSEE 2024 is officially opened. YSSSEE 2024 is officially opened. In this occasion, Rector will also receive the International Patent Certificate granted from United Kingdom Government and 4 international books. And continued with take a picture together. Well, thank you very much, Rector UIN Raden Intan Lampung, together with the Dean and all the speakers who would like to come in front of the stage. In this occasion, Rector will also receive the International Patent Certificate granted from United Kingdom Government and 4 international books. So, Rector UIN Raden Intan Lampung, would you please to move in front of the stage to receive this International Patent Certificate. The certificate will be given by Dr. Vishal together with Bapak Antomi Saregar, Dr. Arti Hadap, and Bapak Freddy Ganda Putra to Rektor UIN Raden Intan Lampung. This certificate is in the respect of the application of such design to device for measuring Baghdad energy. The patent certificate has been signed by Comptroller General of Patent, Design and Trademark Intellectual Property Office in July
18, 2024. It is granted from United Kingdom government, and it's a wonderful collaboration between lecturer and UIN Raden Intan Lampung, together with 4 books, 4 international books. Rektor UIN Raden Intan Lampung will receive 4 international books as the result of a wonderful collaboration between lecturer in UIN Raden Intan Lampung, Bapak Antomi Saregar and Freddy Ganda Putra, together with Dr. Ardi Hadap from Villa Parle, Mumbai, India, and Dr. Vishal Panse from Sakarkeda, India. Thank you very much. Would you please to come back to your seat? The following agenda is giving certificate to keynote speakers. We would like to invite Professor Konstantinos Ravanis from University of Patras, Greece, Dr. Elizabeth Edward from the University of Queensland, Australia, Dr. Vishal Erpanse from Art and Science College, Sakarkeda, India, Fajrul Fala SSE MSc from Akademi Inovasi Indonesia, Dr. Achi Rinaldi MSi from UIN Raden Intan Lampung, and Rector UIN Raden Intan Lampung, would you please to come in front to hand over the certificate to the speakers. The first certificate will be given to Professor Konstantinos Ravanis from University of Patras, Greece. Thank you. And the second certificate will be given to Dr. Elizabeth Edward from the University of Queensland, Australia. The third certificate will be given to Dr. Vishal Erpanse from Art and Science College, Sakarkeda, India. The fourth certificate will be given to Fajrul Fala SSE MSc from Akademi Inovasi Indonesia. And the last certificate will be given to Dr. Achi Rinaldi MSi from UIN Raden Intan Lampung. Continued by taking picture together. Rector UIN Raden Intan Lampung together with the keynote speakers, we would like to take a picture together in this stage. And after this, we would like to ask you to taking picture together with the participant. Thank you for Rector UIN Raden Intan Lampung together with the keynote speaker. We'd like to move in front of the stage to take a picture together with the participants. And all the participants would like to stand up, please. We'd like to share this memorable moment by taking a photograph together. And all the deans together with the head of center in UIN Raden Intan Lampung, would you move a little bit in front? May I guide this photo session? And the second, give us your spirit. And the third, L for Lampung. Give us U for Unggul. Thank you very much. This is the end of the photo session. You can come back to your seat. Rektor UIN Raden Intan Lampung, thank you for coming in this opening ceremony YC 2024. And ladies and gentlemen, this is the end of opening ceremony YC 2024. Thank you for your attention. And the following agenda is keynote speaker session led by Mr. Arif Darmawan. And ladies and gentlemen, after this we have 15 minutes to coffee break before we continue to the next session. Let's close our closing ceremony of YC 2024 by sharing hamdalah together. Alhamdulillahirabbil alamin. Wallahul muwaffiq ila aqwamit thoriq, wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
kita pulipang isangun maalagi wat sayangmu kayak yang nyandang hati cadang asal de puas bangi iniku kayak yang nyandang hati cadang asal de puas bangi diniku aku dinana yang mudah ucapkan jawab ayo ulinya khabai siang kami bang temon ni jawaku ulinya khabai siang kami bang temon ni jawaku gantaji ya tumbang bunga bumi diambil tiga sejanganmu gantaji ya tumbang bunga bumi diambil tiga sejanganmu lagi wadha khapani hati hadapu bandung jamari khimu tambahkan tawat kundang musai bagi saya mampu ngemis segala-gala olehnya khabaisia ya mampu miskin hinahi papa olehnya khabaisia nyahu miskin hinahi papa gantaji ya tumbang bunga bumi diambil tiga sejanganmu gantaji tumbang bunga bumi diambil di kesejahanmu lagi wadah penuh hati agak bandung jama dirimu tambahkan kau kundang musai baki saya mampu ngemis segala-gala Jong ini ku balin pilih ya khude miskin hina khi papa Jong ini ku balin pilih ya aku miskin ghina khi papa
Mas Arif. Ladies and gentlemen, we will start again to the following agenda. Assalamualaikum warahmatullahi wabarakatuh. Welcome back with me in this keynote speaker session YC 2024. I hope you are very glad and enjoy this event and give more spirit to take the new knowledge from our keynote speakers. And I would like to introduce our great moderator for this keynote speaker session. Our moderator for this session, Bapak Arif Darmawan, is a lecturer at Department of Economics, University of Lampung. Previously, he worked as pro-hire consultant at Ministry of National Development Planning or Bappenas from 2017 until 2019. He is a member of editor team in Jurnal Ekonomi Pembangunan or JEP accredited Sintatri and reviewer for some reputable national journal in economics, public policy, and local economic development. He received gold medal for innovation and invention in business incubator from UiTM Johor, Malaysia in 2022, and awardee of New Zealand funding for public policy training in Jakarta. He is fluent in English and Turkish. Ladies and gentlemen, please welcome and give applause Bapak Arif Darmawan.
Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Today is a very good, great occasion because right now we will enter into the parallel sessions with the distinguished speaker in the Young Scholar Symposium on Science Education and Mathematics and Environment YSSSEE 2024. This international conference held by UIN Raden Intan Lampung. So for today, we have 5 speakers, and I would like to invite one by one. The first, I would like to invite Dr. Vishal Erpanse from Art Science College, Sakarkeda, India. Dr. Vishal Erpanse is the director of the Rakai Kisan Foundation, Nagwin. He graduated PhD in the Physical Science from RTM Nagpur University with the entitled Preparation and Luminescence Characterizations of Green Emitting Phosphor for Solid State Lightning. And right now, he is the postdoc from the Department of Physics Education, UIN Raden Intan Lampung. Good morning, sir. And for the second speaker, I would like to invite Dr. Achi Rinaldi, SSC MSc, Associate Professor at UIN Raden Intan Lampung. Dr. Achi Rinaldi is the Associate Professor at UIN Raden Intan Lampung. He graduated from Department of Statistics, Faculty of Natural Science and Mathematics, Bogor Agricultural University in 2018. Right now, he is the Chief of Information and Communication Technology (ICT) at UIN Raden Intan Lampung. And for the third speaker for the first session today, I would like to invite Bapak Fajrul Fala, SSC MSc. Give applause for the Bapak Fala. Bapak Fajrul Fala, expert science communicator grounded in a solid physics background, known for creative and impactful outreach reaching over 100 million views and 1 million subscribers across social media. Master of Science in Physics from the Cardiff University and also Bachelor in Physics, Department of Physics, Diponegoro University. He is the founder and director of Pusi Pustaka, Vice Director of Akademi Inovasi Indonesia, and also get YouTube Creator Award for 1 million subscriber, Golden Play Bhutan 2024. So, in the first session, we have three distinguished speakers, Dr. Vishal Erpanse, Dr. Achi Rinaldi, and Bapak Fajrul Fala. So, I would like to give my microphone to Dr. Vishal first. Each of the speakers have at least 10 until 15 minutes to present the presentations, and after the first session, we would like to open the discussion and question and answer session. So without further ado, I would like to invite Dr. Vishal Erpanse from Art and Science College, Sakarkeda, India. Please.
Thank you, sir. Honorable inspiring leadership of the rector of this university, honorable vice rector of this university, deans of the faculty of this university, all the respected faculty members, organizing team members of this conference, my beloved friend Professor Anthony Saregar, and all the committee members and all the respected keynote speaker, invited speakers. So thank you inviting me as a keynote speaker to this conference. Myself Dr. Vishal R. Panse. I am from India. Basically I am the associate professor in Art, Commerce, Science College which is affiliated to one of the state university of Maharashtra, that is Santa Gadge Baba Amravati University, and also holding the position of my own firm, that is Radha Kisan Foundation. So I just started my presentation. So presently my research area is, thank you. So my basic research area is the solid state lighting, which is very much familiar with this lighting in this room. All these lightings are the LED lighting system. Most of the persons or most of the researchers know very well what is meant by LED. It's the light emitting diode, which gives the maximum illuminations rather than the previous lighting system. So my topic is the challenges and development of inorganic phosphor for lighting applications. As we know, when the man started his journey as from monkey to human being, He started as a lighting system, it also started his invention from bonfire, torch, traditional of lamps, candle, kerosene lamps, incandescent lamp, then fluorescent lamp, and now we are in the stage of the LED lamp, which is having inventions from the stage 1990 to 2024. During this stage, at each stage we get more and more invention, more and more new techniques to develop this lighting system, LED system. Because when the first LED was invented, it is having more costly, and the characterization process and manufacturing process is too cost. But nowadays 2024, it's too easy to manufacture the LED, which is used for the application in the industry purpose. And before that, when the LED was not invented, at that time in most of the area, basically in India, most of the area we use the fluorescent lamp, that is the mercury lamp, which is contain the mercury, and which is very harmful for the nature and the human health, because 1 tablespoon of mercury is make dangerous for the lake of the water. And this is the Times of India newspaper of the date 23rd May 2024, it's page number 4. In our government of India, they promote LED, use of LED to most of the region of the villages, cities, and most of the villages, they provide the LED to use at maximum level. In government of India, Prime Minister, that is Honorable Narendra Modi, she launches the scheme that LED distribution under the domestic efficient lighting program at Delhi. And as we see the case of Indonesia, Indonesia is now up to 2022. He uses a converted old lighting system to the new lighting system. And as we see the case of Lampung, in 99.99%, Lampung is going to convert or change its old lighting system to new lighting system. And for this case, one of the biggest company in Indonesia, that is Panasonic, and this is the Executive Project Lighting Group CEO, that is Stephanie Julia, is headed this scheme to shift old lighting system to new lighting system. And this is the one of the major collaborative initiatives by the government of India and government of Indonesia. That is, this is our honorable finance minister, and she is also the finance minister of initiative that is strengthening economic ties via joint project. And under this project, we just submitted one of the major project with jointly collaborate with this university and our India University. That is the main investigator from this university is Professor Antony Sareka, and from India, that is myself, and from one of the investigator from the Malaysia, that is Professor Manap. So as in the topic of my research, I work on these 3 methods, that is the solid state lighting, combustion synthesis method, participation method, sol gel method, wet chemical method, and solid state diffusion method. All these methods are used for the prepares of the LED system, which is in further going to use for the industry purpose. All of these are low cost synthesis method and easily accessible in any education institute, any research institute, and easily we have going to provide the facility to the UG student. This is solid state lighting having 2 parts, that is which is going to use in inorganic devices and organic devices, having the good properties required for the good phosphor, that is efficient absorption of UV, good color rendering, high quenching temperature, transparency in visible region, good persistence. Because whenever we going to develop any material which is used for the lighting system, the most important thing is we have known, that is they are must having the high giving high luminescence intensity, which is having emission intensity from 350 nanometer. This is the major part when we are going to manufacture the LED. The most important part we have to know, that is luminescence, which is divided into 2 parts, that is fluorescence and phosphorescence. In fluorescence, that is the emission relativity short persistence between 10 to minus 6 to 10 to minus 12 seconds, while in case of phosphorescence, it is longer duration persistence and it's a temperature dependent, while the fluorescence is the temperature independent. This is the basically luminance mechanism, luminescent material, inorganic luminescence material, that is which contain combination of host material plus defects plus dopants. As we see the case of host light is that Y2O3, Y3L5U, O12, ZNS, CALSIN3, And basically when we going to manufacture any LED, it contains three parts. One is dopant, which is come from the rare earth material, and another one is the host material. Rare earth are basically europium, terbium, cerium, Mn, all these. And as we see the excitation mechanism, high energy, if you see the particle, the high energy particle, gamma, X-ray, and high voltage electron excitation, as we see the electrons are jumping from between covalent bond to valence band. The transfer is in, and middle section is the band gap. This is the one of the example of luminescence material. This is inorganic luminescent material morphology. They are basically size in the nanoscale particle, microscale particle. That depends on the material characteristics, properties. Some of the material going for the micro size, some of the material for the nano size. That depends when we characterize for the same term. Then we know that the particle size of that material. So what is the role of the luminescence in this present era? The role of luminescence basically applicable in the medicines, industrial environmental use, consumer products, art and culture, educational outreach and public engagement, future prospectus invention, and ethical consideration in luminescence research. In today's era 2024, all over the world, most of the universities, most of the industries, most of the villages, cities, all the old lighting system converted into new lighting system. So these are some examples that how we manufacture or how we develop solid state lighting material in our lab. This is one of the example. This is SRMG2AL1602. In this case, the dopants are terbium 3 plus and europium 3 plus. And another one example is Ba3Y1-X borate, and dopant is cerium 3 plus, having concentration from 0.005 to 0.004. In first case, the materials are from the inorganic aluminate base group. There is strontium nitrate, magnesium nitrate, aluminum nitrate, and urea. This urea is the fuel which is used to burn that material when we use for the combustion synthesis method. And the dopant are terbium and europium. And the concentration of terbium is 0.01 to 2 mole %, and europium is 0.1 to 2 mole %. And all these material are from the Merck grade, AR grade. And while in second case, the material are barium nitrate, yttrium nitrate, boric acid, urea, cerium sulfate. And for this case, we just characterize that XRD, X-ray diffraction same, then FTIR, then CIE. This is the resultant discussions of result part of this material prepared. This first one is the XRD, X-ray diffraction pattern of the SR2MgAl16027, and second one is the XRD pattern of Ba3Y0.98, BO3 0.02, and cerium 3 plus. In this case, both XRD we match with the standard JCP data source file available online. Anyone going to check? And this first case is matched with the XRD pattern. Second one is matched with the XRD pattern 97761, and this compound is the novel compound. So we claim this as a novel compound. This is the same micrography of both these compounds. First one is the same micrograph of SR2MgAl16027, and second one is the FECM EDS of B3Y0.90 BO3 cerium dope compound. In both these case, in first case we get the crystal light chip morphology, while in second case we get the foggy like morphology, 0.2 micrometer, and first case we got the particle sizes, same micrograph is 10 micrometer. This is the FTR spectrum of SR2MgAl16027, and second one is the FTR spectrum of the another compound. First case, the spectrum range from 4600 to 400 centimeter inverse was recorded at the room temperature at our research place in Nagpur University. While in second case, is the strong peak observed above 1150 centimeters should be assigned to BO structure quenching of BO3 group, while the spectrum shows the broad gap of 650 centimeter inverse to 1600 centimeter inverse, and the bands at 459, 544, 724, out of which the twisting of group between borate. This is the photoluminescence properties of the compound prepared for the dopant terbium 3. In this case, we got the highest excitation peak at 353, which is used for the solid state lighting. If any material we prepared in any laboratories having the excitation peak at 353 nanometer, that is 353 means denote that this material is suitable for the solid state lighting. And for this 353, we got the emission peak for the terbium, which is showing the highest most intensity at showing 5d4 to 7f bond structure, and 545 is the color range between the green spectrum. It shows the green spectrum, and this is the PL properties of the same compound, but the dopant is different. For this case, we use as the europium having valency 3+, and we got the excitation peak as 396 nanometer. And for this 396, we got the two peaks. Europium shows the two emissions peak. One is at 597 and 614. In this case, we got the molecular concentration from 0.1, 0.2, 0.51 to 2 mole %. In first case, the PL excitation spectrum gives the maximum emission at 614 due to the force electric dipole transition, that is 5d0 to 7f2. This is the PL-PLE of Ba3Y0.98 BO3 second compound, and this is the excitation peak. In this case, the high temperature phase beta, that is Ba3Y BO33, is a coordination environment of Y atoms of changes in crystal. As we see, in this case, the CE concentration ranging from 0.5 to 0.02, and we got the peaks at 338, 376, 456 and 473. This is the first one diagram is the effect of concentration of terbium, because whenever we are going to prepare the compound, this compound is going with the temperature range of 550 angstrom unit. If that depends on the component, if it is from the aluminate group, then we use the combustion synthesis. If this compound is from the borate oxide based, then we use the solid state combustion diffusion method. In that case, as the effect of concentration of terbium 3, we see the emission concentration ranging from 0.5 to 2 mole %, and this is the CI diagram, which shows we get obtained from the emission peaks. And this is the energy level diagram of C3 in the host crystal, that is A3 by 1 minus X PO33, having C is the dopant, and the CI coordinates we found in the first case is 0.1158 and Y coordinate is 0.0735, and both these paper all published in the Scopus Index journal with the collaboration of Anatomy. First one is published in the CIEN Web of Science, that is Journal of Material Science, Material Electronics, and second one is the Journal of Optics, which is indexed in the Springer, and first one is the Elsewhere. This is the second compound. How much time?
3 minutes left.
Only 3 minutes?
Yes, 3 minutes left. I'm sorry.
Okay, I just short it. This is the second compound, that's allied to Mg1 minus X ZrO4 Tb3 and ZrO4 Tb3. I have less time, so I just fast. This is the first one compound and having a lithium nitrate, magnesium nitrate, ZrNO3, and this is ZrO2 having urea and terbium oxide. This is the XRD structure of the first compound, that is ZrO2 and allied to Mg ZrO4. This compound is also this is having emission and excitation mechanism, and this compound is also published in the Journal of Result in Physics and Optics, both are in the Elsewhere with collaboration with this university. This is the third one compound, that is MgPb. This is the novel compound MgPb-L10O17 and terbium 3. We also claim this compound as for the international patent from the government of India, and also indexing both paper published in the Scopus. First one compound is MgPb-L10O17 and second is Ca2Pb3PO4Cl. This is also novel compound. This is the XRD diffraction structure of the MgPb-L10O17 Ca2Pb3PO4C3Cl3. Both compound taken from the aluminate base. This is the same micrograph of first compound. This is MgPb-L10O17 and Ca2Pb3PO4Cl. This is the PL structure of MgPb-L10O17 and Tb3. This both compound is also published in the Scopus Index journal. That is, first one is the Journal of Luminescence, which is indexing in the Elsewhere, and another one paper is also indexing published in the Optics, which is indexing in the Scopus. This paper is also published in collaboration with this university. This is the last compound, CDSE 0.3 TE 0.7. This is thin film, and this is Y2O3 AR3. This is the TEM images of Y0.93 ER 0.2. This is the PL excitation spectra and emission spectra. In this case, we got 356, 375, and 261 nanometer, 255 nanometer. And for this case, we get the spectra at 506 nanometer, 522, and 711. This is the effect of doping concentration of PL intensity and CI diagram. In this case, we got the peaks at x coordinate at 0.291 and y 0.397. This is the effect of thickness on structural, morphological and optical properties spray deposited, because the spray, this is the spray deposited method. In this case, we peaks that is A, B, C, D, E, F. All these cases we get the peaks at higher most intensity approximately 5000 angstrom unit. This is the FESM diagram of this compound, that is A, B, C, D, E, F. This is the CD, SE 0.3, T 0.3 thin film deposited at different thickness, that is in first case A is the 355 nanometer, B is the 460 nanometer, C is the 672 nanometer, D is the 908 nanometer, E is the 1033 nanometer, and the last one is the 1207 nanometer. This is the energy dispersive X-ray analysis, EDAX. This is the UV visible spectroscopy for 355 nanometer to 1207 nanometer. This paper is also published in the, first one image is not displayed. Both this paper is already published in the Integrated Fellow Electronics, that is indexing in the Springer. This 1 minute is remaining. Give me. This is the last compound, the Ca2Al2O5 SM3+, and Ca4Al14025 dysprosium. This is the excitation and emission spectra for both this compound. First one case 409 nanometer to we get the emission at 606 and 568 nanometer, and second one case 347 excitation peak, we got the emission at 567 nanometer. This is the energy level diagram of SM3+, and the CI diagram. For this case, we got the peak at the 262 to 723, and both these paper are already published in the Scopus, that is with this Anatomy Sarega. This is my major collaborations with the India and Indonesia, from Professor Ravindra Pandey to Anatomy Sarega, Professor Arti Hadap. Last one image. This image is not displayed. Okay. Okay, thank you.
Okay, thank you so much, Dr. Vishal. We do apologize since it's quite intense the time before the lunch. So I think we have 5 speakers today, and since the opening ceremony is quite little bit late, we do apologize for the inconvenience condition, but we will pay back to you when we have the discussions. So maybe the participant will have the interactions, discussion with you. So we do apologize for this inconvenience conditions. Yes, unfortunately. So I would like to going back into the second speaker, Dr. Achi Rinaldi. So Dr. Achi will be our second speaker. So he is coming from UIN Raden in Lampung. So Dr. Achi, please, time is yours.
Thank you very much, Mr. Arif. I go first. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrabbilalamin. Salatu wassalamu ala asrafil anbiya wal mursalin wa ala alihi washabihi ajma'in, amma ba'du. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Subhanaka la ilma lana illa ma 'allamtana innaka antal alimul hakim. Good morning everyone. The Excellencies keynote speakers, the Excellencies moderator, and also Ketua Lembaga Penelitian Pengabdian Masyarakat, Prof. Humedi Jafar, and some member of Senate, this Professor Agus Parudin, Professor Yuberti, and also all the lecturer, all the participants in this international conference. Tabi pun. Okay, I would like to present my work. which the title is Spatio-Temporal Model for Estimating Climate Change and Natural Disaster. And maybe this is hot topics in this era. And also it's related to the vision of UIN Raden Lampung that concentrate to the environmental science. Okay. The impact of extreme weather and climate change is one of the most serious problems for people lives around the world. In Weather Meteorological Organization in 2009 conference said that, and in IPCC 2007, the increased intensity of extreme weather events such as drought, heat wave, flood, landslides become more severe and frequent due to climate change. And it underscores the spatial and temporal variability of precipitation as a critical factor in these changes. So I would like to propose my study and my work in statistical model. It's called spatio-temporal model. And this is SDGs, the 17th Sustainable Development Goals, reports in 2025. The Sustainable Development Goals, or it's called SDGs, also known as global goals, are a set of 17 interrelated goals to end poverty, protect the planet, and ensure that humanity enjoys peace and prosperity in 2030. Reporting on SDGs is important in communicating to stakeholders the company's commitment to contributing to the global goals, claiming accountability, responsibility to take the necessary actions, and measuring progress over time. So some our works in point 8 and point 13, I think it's related to the SDGs, this 17 Sustainable Development Goals. This is our research, maybe related to the SDGs points. We are modeling extreme rainfall with a regression, PCR, principal component regression in 2015. We use generalized extreme value to estimate extreme rainfall in DKI Jakarta province in 2016. We make models, it's called spatial extreme model, to make extreme rainfall zone. It's some map. It has implemented in province West Java, and also in spatio-temporal model, conditional autoregressive for estimate extreme rainfall in the West Java in 2018, and also in West Java too, we use extreme rainfall pattern using extremogram. It's approach like a time series, but we using some not a normal distribution with a classic assumption. It's we use extreme distribution like a GEV and generalized Pareto. And in 2019, we use GEV, generalized extreme value, to estimate the extreme rainfall, and also some works like to calculate air pollution index of Samarinda city, and to estimate some poverty and welfare. This is my work at the spatial modeling in 2021. The comparison of spatial error model and geographic weighted regression. We use the data in East Java. And 2023, last year, on this international conference, we published application of autoregressive integrated moving average. This is a approach of time series in statistics. This is for earthquake forecasting in Lampung province. And in 2023, we use a spatial model too to estimate the poverty in Lampung province. And today, And these years, we have our work too in ARIMA method in predicted farmer exchange rates in this conference series, an application of the singular spectrum analysis in forecasting rice production in this conference. Okay, this is, I think, the importance of the spatio-temporal model. And to the climate change and natural disaster, the important thing is where the location is. The model is to answer the where the location is and when is it happen. So it's called spatial and temporal. So the combination of the spatial and temporal is called spatio-temporal. This is some formulation models that we also known as a basic model in statistics is classical regression, and the estimator we usually use ordinarily square, maybe a classical method, and we have the estimator for beta at beta and variance of beta as x and x inverse. And the second one is we go into the general spatial model, which can handle for a regression or classical regression. So we use a weighted for the spatial weighted to the regression. So it's called general spatial model. Some works in 2021 we use a general spatial model, and also in the general spatial model have two forms. It's divided two forms. The first one is spatial autoregressive, which the spatial weighted on the variables, and the spatial error model. The second is the spatial error model, where the weighted or spatial weighted it in the error, not in the variable. Okay. Also as I have worked in spatial autoregressive and spatial error model in 2021 about poverty, welfare, some disease like malaria or demam berdarah, dengue. This is some models from it's called time series. It purpose to forecast in time. The popular is autoregressive integrated moving average, autoregressive and moving average. Autoregressive when the weighted of time weighted it's in the variable, in moving average the weighted of time in error. And this is a combination of the two, spatial and time series. It's called spatio-temporal model. Actually, it's many of the model of spatio-temporal model, but I just present three of them. It's spatio-temporal model with a linear trend, spatio-temporal with additive model, and spatio-temporal model with interaction. And it also I have applied, or I have implemented this on our work. Okay. Nah. This is extreme value distribution that we cannot modeling the extreme event like a natural disaster with some classical distribution like a normal, but we use some distribution. It's called Gumbel, Frechet, Weibull, or the combination of it. It's called GEV, generalized extreme value distribution. So it can modeling for extreme event maybe like extreme rainfall, earthquake, and many more. This is in 2019. This is some product or outcome. I have a mapping in West Java, use extreme value distribution, generalized extreme value distribution, with also with we use a spatial model using a generalized extreme value, and we combine it with some methods like kriging, thin plate spline, and some non-parametric methods, and we product this map It's called extreme rainfall zone, and it's already used in meteorological climatological organization Indonesia, BMKG. Alhamdulillah. This is second outcome. In 2018, we have some create some new model which can be accommodated by extreme event. In extreme event, we know that autocorrelation function in time series it cannot be used to extreme event. So we have some new formula. It's called extremogram. HEF autocorrelation function has become extremogram, and we can also use it to estimate and make some map and forecast the map, and also the pattern of the rainfall. Like this is a map of West Java. We can see that December extreme rain or high intensity of rainfall might be fall in the blue, and also the uniquely is in Bogor, it's May, but the result is the Bogor it's always rain, almost have a rainfall in every day, so it cannot be some conclusion about this Bogor is a May. Okay. This is some outcome from spatiotemporal, so we can use it as a map or some zone, and we can predict which area will give us rainfall much or less. 1981 until 2012. Okay. The future work is make another zone for extreme rainfall in different place. I just have one for West Java province, maybe in Lampung and another, and also for other extreme event like earthquake. In 2023, I have modeling it with ARIMA, autoregressive integrated moving average, but I think we going further to make it use it with extreme value distribution. And the second is forecasting for extreme event with a time series model with extreme value distribution for earthquakes and another retrocession. And the third, combination of spatial and temporal model for other extreme event or natural disaster. Thank you all. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Terima kasih. Thank you so much, Dr. Achi from UIN Raden Intan Lampung. Very short and great presentation. Thank you so much for helping me to make a good position in the time management. And the third speaker, I would like to invite Bapak Fajrul Falah from Akademi Inovasi Indonesia. So please, Bapak Fajrul, time is yours.
Let's wait for a moment. Okay, thank you for the time. What makes people engage with science? This is a really tough question. As teacher, as educator, we know that science is important. It's crucial for navigating our world and develop critical skills. However, students often don't see it the same way. And in the era of smartphone and social media, scrolling through TikTok, YouTube, Instagram is more appealing than studying science, of course. To add a bit more context, I have a background in physics, from Cardiff University in the UK, and I'm a practitioner in the field of science communication. So my team and I run a YouTube channel where we talk about physics. We talk about the physics of, well, pretty much everything, from physics of movie, physics of game, physics of anime, and many viral stuff. In 3 years, we managed to grow the channel to 1 million subscribers and more than 100 million views. And all of that, all science content. So, even though teaching in classroom and on social media are different, there are some key takeaways that we can learn from these experiences to make people, especially students, to be more engaged with science. To do this, let's take a look to 10 of the most watched video on my YouTube channel from about 200 video uploaded. And we will see an interesting pattern emerge. So, 4 of the most watched video on my YouTube channel are this. So, let's see. In this video, I explain about a viral meme about free energy car that will be moving infinitely when we put a magnet in front of it. Then there is a video debunking a national news when someone claimed that he can turn a drop of water into a fuel for motorcycle with a range of 50 kilometers. Then there is a video explaining about a global news about Titan submarine, Titan submersible in 2023, the implode in the deep sea. Then there is also a video explaining about many viral stuff. And then the question is, what do all of these videos have in common? Relevance. So, all of this video talk about relevancy. When we teach science in class, students often ask, when will I ever use this? Why do I need to know the value of integral x squared? What is the importance of Newton's second law of motion? And many things. When students asking this question, they are seeking relevance. They want to know how a science concept connect to their own lives. So, the first thing is relevance. Let's break it down with example. In 2023, there is a global news that spread everywhere about Titan submarine that implode in the deep sea. When this news spread, everyone asked, how did it happen? What is the danger of the deep sea? What is implosion? And this is an opportunity for me to explain about science concept. So I make a video explaining about it, everything about this, but from POV of physics. So I talk about what is pressure, what is hydrostatic pressure. And in the video, I literally did just a simple calculation about how big is the hydrostatic pressure in the depth of 4,000 meters. By using this approach, somehow people more open to learn about this science concept about hydrostatic pressure. That's because I show them how it will translate to real life. So, relevance. We need to give students the full context of what is the topic about, how it relates to the real life. However, relevance alone is not a complete picture. Because if I just consider relevance, then all of my other top video would be impossible to get so many views. So let's take a look to the other 6 of the most watched video on my YouTube channel. These are the video. Okay, let's see and let's talk about relevance here. Do all of this video provide relevance to the real life? Well, I think no. Do we ever need to do Naruto style run in real life? No. Is Naruto style run faster than normal run? No. So, why does 1 hour in interstellar movie equals to 7 hours? proving science experiment from Detective Conan and Dr. Stone anime. And let's talk about relevance here. Do all of this video provide relevance to real life? I'm sure no. But somehow, people watch this video, and all of this video, each of them get millions of views. Why? So I take a moment to think about this. And the answer is story. All of this video may not have direct relevance to real life, but all of this video have story. And this aligns with what I learned from Professor James Kakalios in his books, The Physics of Superhero. In his book, in the introduction part, he writes something like this. If we teach science in classroom, students may ask, when will I ever use this? But when we explain about a superhero that use this abstract science concept, somehow they all forget all of this question. They will just accept and learn about the concept without ever noticing that. They may not use that in real life. This also similar to what I learned from a successful YouTube channel, 3 Blue and Brown. This is my inspiration on YouTube. This is a mathematics YouTube channel, and he shared similar result. The most watched video on his channel is not the one that give relevance, but the one that provide the story. Relevance is about logic, but story is about emotion. And this is a whole different thing. By using story of Naruto, I can explain about the physics of aerodynamics. By using story of Interstellar, I can explain about time dilation and many more. And when we talk about story, it is not just about the story of the medium, but also the story of the topic or the lore itself. So let's take example, Maxwell equation. Okay, don't bother with this equation, okay? So, if we explain about Maxwell electromagnetic equation, it might be boring on its own, of course. But if we turn this set of equation into a story on how Maxwell doing observation and then he formalize it in form of 4 set of equation, then from here he predict the existence of electromagnetic wave, and from here he can calculate the speed of light. It turned a set of story into a meaningful journey, a meaningful story, and that's a whole different thing. So the second thing is story. We can use the story of a medium or pop culture, or we can use the story of the topic itself. However, once more, getting attention and engagement is a whole different thing from making students actually care and want to learn about the topic. So there is a final missing piece that will complement these 2 components before. It is authenticity. We need to tell people about science as it is. We can use technique of relevance, of technique of story, but we should never exaggerate it. Because if we exaggerate something, they may be disappointed and they will not learn about it anymore. For example, like, it's easy to get people interested if we using about a bombastic story or a bombastic claim. For example, like, ancient Indonesian people have the power of quantum technology. Ancient Indonesian people can send curse or santet because it is quantum entanglement thing, something like that. People might be interested in this topic, but they will never learn about it anymore. Why? Because when they try to learn about this topic, they will find out that, wait, this is different thing. You are lying, something like that. So, authenticity is a crucial thing. We should tell people about science as it is. This is like, we should tell people that, yeah, science has its easy part, but it also has a difficult part. Science has aspect that is enjoyable, but science also has aspect that are confusing or frustrating. We should tell them as it is. And that's how we make people engage with science. We can use relevancy, we can use story, but make sure we use authenticity. Thank you.
Okay, thank you so much, Bapak Fajrul Fala, for showing. I think we should watch one of your video, yeah, to see the relevance, the story that you mentioned in your presentation. But maybe we will have the time for that. So right now we are going into the discussion for the past recipient. So I think I would like to invite all the participants in YSSSEE 2024 in our venue. If you have any questions regarding about the presentation from Dr. Vishal, Dr. Achi, and also Bapak Fajrul, please you may raise your hand and the committee will go to you to bring the microphone. Is that any question? Yes, one, two, once again, once. The gentleman? Okay, so maybe we will go into the participants. The committee, could you please give us the microphone? Prof. Yuberti, number, and also, yes. Okay, the first, Prof. Yuberti, and then also the ladies there. Okay, please.
Okay. Baik. Okay, thanks you time given for me, and I appreciate presentation of apa nih? Okay. My question to Mr. Vishal, I appreciate your presentation. It's a very good for we, and I hope the develop knowledge about science. About analysis, I want to. What's the analysis? Is your research photoluminescence? And what's the object or material specific and others implementation your analysis. Sorry Mr. Arif, maksud saya begini, tadi agak terlalu cepat ya saya menangkapnya. Sebenarnya ini berkaitan dengan kimia gitu ya. Jadi saya tadi kurang detail terkait dengan analisisnya. Jadi beliau mengatakan bahwa beberapa objek mampu memancarkan sinar biru gitu ya dari fosfor gitu. Tetapi terkait dengan photoluminescence, the analysis. Jadi persisnya yang digunakan itu sebenarnya analisisnya seperti apa gitu. Sorry seperti itu. Dan terkait dengan objek or specific materials yang digunakan itu sebenarnya apakah ada khusus gitu yang dipakai dalam penelitian yang bersangkutan. Sorry ini combine English and Indonesian karena pesertanya juga lebih banyak yang Indonesia gitu.
Okay, thank you so much.
Thank you very much.
Okay, so Prof. Yuberti from Raden Lampung actually asked because your presentation is quite fast, so she need the more detailed information about the photoluminescence.
Okay.
The analysis and also what kind of the materials that actually used for your presentation.
Okay. Thank you, and I really apologize due to time limitations. He gave me only the 15 minutes, and as I consider and prepare the presentation for the 40 to 45 minutes, because I includes about the 10 materials which I prepared in my laboratory. And all these material already published. But as we see, going to see the basic concept of luminescence. Luminescence is depend on the emission and excitation mechanism. It's could be helpful to design and develop this solid state lighting material. The concept is the designing solid state lighting material, which is basically in simple words we call as a LED, which is helpful for designing this lighting system. Basically in present room, all these are the solid state lighting material, and this compound is already prepared. Already we see that it's all this LED material, but this compound which I was shown in my presentation, this material prepared by the low cost synthesis, because this is your university, no doubt. University having the lots of fund for the research and development, but as we consider for the any one of the college from the rural area, which is didn't having any fund, research funding, faculty, lack of faculty, in that case, we also have possibilities to design such type of material with low cost synthesis. As we see the one of the simple method, as we see that just discuss about the one objective and simple method, as we discuss about the combustion synthesis method, which is easily we utilize and design at our institute level, which is having some simple as a aluminum box, as everyone house having the aluminum box. This aluminum box is utilized in our combustion synthesis method. And as we talk about the material, so aluminum based compounds such as example Sr2MgAl16O27 means I take the Sr from the strontium nitrate, Al from the aluminum nitrate, then Mg from the magnesium nitrate. I just take all these compound from the aluminate grade aluminum, from Merck AR grade, which is useful for the synthesis method, and also takes the rare earth material, that is terbium nitrate Tb3 plus, and just prepare all this compound with specific concentration with the help of combustion synthesis method, and just heat that material with 550 degrees Celsius in my research place. After that, just take out that compound, get the fine powder, and crush that powder in my research place, and after that powder sent to the characterization process for getting the FTIR, XRD, same, TEM, and all these. And as I get the result, just match with the XRD with the standard JCP data source file, measure the same size, and from that result I just conclude that this material which is having excitation about 353 nanometer, which is as in the universal constant, that which is suitable for the solid state lighting material, because the material which gets the excitation above 350 nanometer, which is suitable for the making material for the solid state lighting material. Basically the street light material lighting as also solid state lighting, traffic light is also solid state lighting. This lighting is the solid state lighting, having the more excitation and emissions, giving the more light.
Okay, about example material simple, what's the real objects?
The real object that actually using in the materials that you use.
Object of the material, to choose of the material, that depends on the for which purpose we have to design the material. If LED material is also useful, this LED screen is also making from the LED. Most of the person in everyone home, we have the TV. Most of the TVs are manufactured from the LED material. In that case, we also provide the material.
Okay, thank you. Like in a screen, it's the real sample, the object. Okay, thank you very much.
Okay, thank you, Prof. Huberti. The next questions from the ladies over there.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. My name is Vandan, Physics Lecturer, Fakulty Tarbiyah and Teaching UIN Raden Intan Lampung. Thank you for the explanation regarding the component that support product used in one brand is Panasonic. From the results of your research, in your opinion, the best component material that can be used for a long time, for example, signal on a TV or other electronic. One of well-known brand is Panasonic, because I happen to be majoring in condensed matter. For a question for Sir Fajrul next. What is process of finding ideas and updating them to the media? Because sometimes we have idea but it's difficult to take action. So learning physics is interesting. Thank you very much.
Okay, the question is for Dr. Vishal and also Bapak Fajrul. Dr. Vishal, the question is about the components, self-components that giving the long extreme conditions with the, your research. So could you mention maybe the component that will give the long-term duration or something?
Okay, this is a nice question and thank you for, basically it's a suggestion for me. There are two types for the material. If everyone, I think when we go in your room, when we switch off the light, in some of the cases, as we switch off the light, then also we get, for some time we get the lighting. That concept is called as a long lasting. And when we go to select the compound for the solid state lighting material, that depends on for which industry, for which purpose we have to provide the material. As I said that this is the solid state lighting system which is used in this room to provide the lighting, and as I say that this is the LED system, or we just simply called as a television, TV, screen. For this purpose the material is the same, no doubt. But the manufacturing process and the dopant, which is I think simple in word we call as a rare earth, at that property and the excitation for which excitation we excite that material to get the emission, because that excitation and emission decided that for which purpose we have to use that material. If we thinking about that, we have to provide it for the television industry, such as the Sony, LG, Panasonic, etc. But they also use the same material. But for that purpose, we provide the material with different excitation, because, and for the LED system, we provide the same material with the different excitation, because both are having the manufacture from the same. Because just like as in simple home, there are two brothers. Father and mother are the same, but both person, one is going from the Air Force, one is going from the teaching. Okay. And the another one question that you asked me, that is how we select the compound. Basically in photoluminescence, there are the, in general, we selected compound from the oxide, we selected compound from the nitrate based, we selected compound from the sulfate based. As you think about to work on the luminescence process, you just see the periodic table, okay? And in that periodic table, mostly rare earth are the costly material. But, and after that, you just see the JCPDS data source file available on the internet. So first you take the which compound is already made, available. If the compound is already available, then you go for the next compound and see the emission excitation characteristics, if anyone having the already work on that. Then you decide it. But just see in simple word, take the reference of the previous work done by the faculty member or the researcher and what industry wants. Because in our university, we basically work on the fundamental basic research, as in physics person. And as we shift from basic science to engineering, because engineering persons or engineering professors, they work on the application base. And science plus engineering, they provide their material, they provide their concept to the industry. And if anyone, there will be science professor and engineering professor, as my colleague says that he has the YouTube channel, and if you provide the publicity through your YouTube channels and all this material, then industry knows what you work on. Then they contact you. Is your idea clear?
Okay, thank you very much. Your opinion about amazing idea.
No problem. If we could, due to time constraint, I just keep all this side. After the conference, we just discuss, because I want to also discuss with the Professor Yuberti.
Okay. Yes. If the participants have the questions further, we will continue after this session. So this for the second questions.
Okay, thank you for the question. So the question is, how can we find ideas? The one core thing that we can use to find ideas is awareness. We should aware about what students care about. We should aware what's happening in the social media, what's on the news, what's the student do on daily life. We should aware and actually care about them, and then we will find those ideas. And if the challenge is about how to take action, it depends on the context. If the context is how to translate those ideas into a video, then the solution is just to make the video. You can use your phone to record the video, and in fact, I just use my phone when I start the YouTube channel with no advanced editing. So I just, from ideas, then I will just take the video. But if we want to implement those ideas into classroom, this is a whole different thing. So what we should do is, this is what I also do in my classroom. I used to ask the student, what do you want to do in this class? What do you want to learn about this topic? And some of them maybe say, we want to watch a movie about this topic. So that's how then I look for the movie that relate to this subject. And then from this activity, we will discuss, and this activity will give them a spark that will make them interested about the topic. That's the first thing that we can do. Thank you.
Okay, thank you, Bapak Fajrul. So for the last question, will be the end or our first sessions. So we still have two distinguished speakers for today. So I would like to give applause to Dr. Vishal, Dr. Achi, and Bapak Fajrul for very great prominent presentation regarding about their research and their experience. So after this, I would like to allowing the distinguished speaker to come back to the chair, and then I would like to invite the second speakers for today's session. Thank you. So right now we are quite hurry and immediate for enter into the second parallel session for the speaker session, keynote speaker. So I would like to invite Dr. Elizabeth Edward from the University of Queensland, Australia, and also Professor Konstantinos Ravanis from University. Okay, before we start our second session for the keynote speaker, I would like to introduce Dr. Edwards. Dr. Elizabeth Edwards is a registered teacher and psychologist. She is an associate professor in the School of Education at the University of Queensland, where she is currently the director of the research. Her research sits in the intersection of education and psychology, and her collaborators and national and international experts in these disciplines. So, Dr. Edwards has an international reputation for the translation of theory-driven basic science into treatment for clinical problems, and specifically for the treatment and well-being of children and adolescents. For example, she has conducted projects on the prevention and intervention of childhood anxiety, healthy screen time, the well-being of children and teachers following the natural disaster, and sustainability educations. So her presentation will take us through one of her recent projects. And for the second speaker, I would like to introduce Professor Konstantinos Ravanis. Did two types of undergraduate studies in basic and in educational science at the University of Patras in Greece, completed his master's degree in science education in the University of Paris, Denis Diderot, and received his PhD degree in basic education for the Department of Educational Sciences and Early Childhood Education at the University of Patras. He also chairman in the Department of Educational Science and Early Childhood Education, vice rector, member of the Council Foundation of the University of Patras, and since 2007 he is the editor-in-chief for the Journal of Egg International Journal. So without further ado, please give applause for our speakers, Dr. Elizabeth and also Professor Konstantinos. So for the second session of the keynote speaker session, I would like to give my microphone first to Dr. Edwards for deliver her presentation. So for Dr. Edwards, please, time is yours.
Thank you. First, I would just like to pay my respect and say Salam Alaikum. And also to say how very, very grateful I am to be here. And I appreciate the welcome that I've received from everybody since I've arrived here on Sunday from Australia. And to also honour the brilliant and aspiring scholars in our midst. So it's a great pleasure for me to present to you today. What I'm going to talk about is one of our recent projects called In Sustainability Education. So some of the initial introductions many of you may know, so I don't mean to be speaking down to you. I'm literally just grouping everybody's together. It helps if you turn it on. I wanted to acknowledge my colleagues in Australia, Professor Matthew Sanders, Dr. April Huang and Professor Anne-Marie Carroll. Together, the four of us were honoured in receiving a grant from the Queensland Department of Education called an Education Horizon Grant, which enabled us to fund the project that I'm talking to you about. So I'm going to go through just a quick overview about sustainability education, and in particular in the Australian setting. And then I'm going to explain the two phases or two stages of our project, and also talk about some professional learning materials, which if you'd like a copy, I'm more than happy to email you if you keep in touch. So one of the deliverables was this best practice guide to promote education for sustainability. It's about a 100-page document, and many of the text and results that I'm discussing are in that document, which I'm more than happy to email to you. So we know the origins of sustainability go back probably until sort of the late 1980s, but now it's very much known as the triple bottom line model. And I've seen this a couple of times in the sessions yesterday and today. So we know that this is categorised as the three areas: the environment, the economic and the social considerations for sustainability. But why is it important to invest in children for sustainability, is my question. It probably goes without saying that many of you, being from an education background, you realise that children are our future. And the quote from the UNICEF, "The world's children must make their way in a world that will become far more dangerous and uncertain in years to come." Therefore, we look at children's sustainability education as having a multiplier effect. So we're investing in the future. By that I mean, if we tell one child, that child then can tell others, who can then tell others. And as they grow up and they have larger networks of family and friends and peers, that means we're getting the word out. So better sustainability practices and a reduction in greenhouse gases at the individual, institutional and communal levels of society. In 2021, sustainability became a cross-curriculum priority for the Australian curriculum. So the Australian curriculum is for preschool right through to year 12 or high school, secondary school. And by saying a cross-curriculum priority, it means that it was, if you like, governed that sustainability would be embedded in everything that is taught for children in our schools in Australia. However, to just bring that in as a policy didn't guarantee that it would occur and that it would be implemented. And one of the reasons we wanted to run this project was to find out what are some of the barriers and challenges for teachers in terms of implementing sustainability education. So the framework looks a bit like this. It was reworked a couple of times, but it ended up in 2022 looking like this, as being modelled in terms of systems, worldviews, design and futures. And if you do want more information about this, it's further elaborated on in that best practice guidelines that I offered to share with you. But we found that the challenges that were being reported in the literature, not necessarily in scientific, scholarly literature, because there hadn't been much research done, but in terms of just the talk, the talk around the place was that there'd been minimal implementation and that teachers lacked understanding, training and competence in able to enact sustainability education in their classrooms. There also was changes required at the systemic and the individual level, so both at their sort of school departments and regions and also at the teachers in their classrooms. So our project, we gathered an interdisciplinary team from psychology and education. So April and Matt, who were on that initial acknowledgement slide, are from psychology, and Anne-Marie and I are actually from the School of Education, although both of us are psychologists and use psychological methods. And we wanted to address the gap in the literature, which was what are the facilitators and the barriers. So if we could determine what they were, we could obviously do more of the facilitating to implement sustainability education and try and reduce the barriers. As a snapshot, we determined that the needs of educators in Queensland schools was self-efficacy, confidence and agency to enable them to implement sustainability education. I thought I would just jump ahead a little bit and share with you one of the first deliverables, and it was interesting in the last talk when we heard from the YouTuber how important it was for children to watch something that was going to be engaging, have a story, or your other things, be relevant, So we actually engaged animators because we thought that one of the first things we need to do is help teachers and students understand what sustainability is. So I thought I'd share this little animation with you. It's only a few minutes long.
It's the beginning of a new school year. The school principal is talking to Sam and the other teachers at their first staff meeting.
And the last thing I wanted to mention before we wrap up today is that we need to ensure we are addressing the cross-curriculum priorities, including sustainability education in our classroom teaching.
Sam's not sure what sustainability education is, so she leans over to Charlie and asks,
Charlie, what is sustainability education?
It's just about looking after the environment, right? Sam isn't completely convinced by this and decides it's probably best to do her own research.
Sustainability is about the ongoing capacity of Earth to maintain all life. Living sustainably is meeting the needs of the present generation without compromising the needs of future generations. Surely there's more to it than that.
Upon further reading, Sam discovers that sustainability is about balancing the needs and impacts of environmental responsibility and protection, economic growth and prosperity, and social justice and development.
Hey Charlie, after our conversation yesterday, I did some reading and found out some interesting things about sustainability education, if you'd like to hear.
Sure. What did you find?
So, sustainability is not only about protecting the environment, it's a balancing act between environmental responsibility, social justice, and economic prosperity. The world is facing increasing complex issues like biodiversity loss and systemic inequality, so the idea is that we, as teachers, need to equip children with the knowledge and skills to grow into responsible adults who can meet today's needs without compromising the needs of future generations.
That makes a lot more sense than what I said.
Yeah, I'm keen to explore this topic further, but I do feel more confident now addressing sustainability with my students.
So although I jumped ahead to one of the deliverables, I wanted to whet your appetite with some of the resources that we developed as part of the funding for this project. So by establishing the fact that, number one, teachers were not really aware what sustainability education was, we thought we would first of all give them a little animation to include in some of their professional development. So the project was based on these research questions. I sort of alluded to this earlier. What are the barriers and facilitators for implementing the sustainability cross-curriculum project? What are the skills, strategies, and what is needed to effectively implement sustainability education? And what are the features required of a professional development program or a professional training program? So we used a mixed methods where in stage one we interviewed teachers and school leaders and we asked them what were their barriers and what were their facilitators. We also asked them what skills they needed, and we determined actually a couple of case studies along the way, which often when you are recruiting participants you get not only people that don't know about the topic, but people that know a lot about it. And I'm going to share with you some of those practical examples. We then did a thematic analysis to determine the answers to that research question. And then we went one step further. We did an online survey and with a larger population of teachers, and we ran a regression analysis on that data, and I'm going to provide you with the results of those. So we interviewed 16 teachers. You can see there was a real mixture of teachers across primary, secondary, state schools, independent schools, a range of subjects that they were taught and year levels and ages of children that they taught and years of experience that they had. We just to give you a bit of an idea of sort of what the teachers' perceptions were of sustainability, recycling. That was about the extent of their knowledge, unfortunately. And as we know, it's a hell of a lot more than that. So the number one was looking at what can we do to ensure that teachers see sustainability education as a lot more than recycling. We wanted to improve their knowledge, improve their skills. We determined that teachers knew that students needed higher order thinking skills. And so we knew that what was going to impact on their ability to implement sustainability education was students' ability to reflect, be reflexive and be empathic. And there's just a couple of quotes that the teachers gave us. So I think sustainability is going to break cycles. We get them to recognise that their small footprint changes in individual behaviours and then the community and our school context or family behaviours can have a flow-on effect. So some teachers knew more than just recycling, thank goodness. And it became very clear that the training required to implement sustainability education effectively was almost zero. So it was really down to the individual teacher themselves to go out and find out more about it and implement it. So they were, in other words, self-sourced professional learning. So we decided that was going to be part of our deliverable, was to develop a professional learning package. So we categorised the barriers in terms of individual factors, organisational factors, systemic factors, and you can see the breakdown. Organisational and systemic factors, of course, were of real concern for us because individual factors, that meaning the teachers themselves, we could give them that additional learning that they require to implement sustainability education, but there need to be a much greater impact than just at that individual teacher level. So the fact that we were being funded by the Department of Education gave them some really clear guidelines of what they needed to do next. So these were some of the breakdown of individual factors, the teachers and students themselves, the engagement with motivation, and the organisational and systemic factors being funding, pedagogy, strategic planning, the curriculum itself, ACARA, and the priority. So we couldn't do a lot about the organisational and systemic factors other than pass that information on to our funder, who's the Department of Education. But we certainly, for the deliverable for this project, we worked hard on those individual factors. We're also in the running for a follow-up grant, which hopefully we hear about in the next couple of months, which would enable us to take this research a little bit further. So this was from our interview data. We determined that the skills that were needed for teachers was planning, organisational, interpersonal skills, and a growth mindset. So I'm assuming you know that language, the growth mindset? Yes? Yeah, so the growth mindset being a belief that you can actually do something as long as you put some effort in and there's motivation and you can actually learn it. So all of us here would have a growth mindset because we believe in higher education. I guess that's what we've identified in teachers, is that they need that growth mindset. They can't just say, well, actually, I'm an English teacher and I'm going to teach literacy and teach them all about these wonderful fiction novels. They also need to have ownership in thinking how they can incorporate sustainability education in their curriculum area. So we found, as I alluded to earlier, some clear examples of good initiatives, and we developed a couple of case studies. So this particular one We found some schools doing things like garden clubs and cooking clubs. We had one running something called a frog hotel. Many of them doing recycling, organic waste programs, and a couple in primary schools concentrating on persuasive writing, and in particular giving them topics about addressing environmental factors. In secondary schools, we had some high school teachers allowing ownership and having student-led initiatives such as students becoming change agents and fundraising for environmental sustainability ideas. So we were really excited to hear that there is some good things going on. One of the other case studies was at one particular school, a teacher who had been very active in developing an environmental club, and he had every part of the school engaging in that actually, from tackling food waste, composting, gardening. So we've written those up as a couple of case studies because we wanted to deliver something that teachers could read and go, well, I could do that at my school. It's not out of my reach to do that kind of thing. And in fact, I don't even really need that much funding to start something like that. The second stage, the online survey, had a much larger sample, and we used as many validated psychometric scales as we could. So we found a teacher implementation of sustainable practices psychometric scale. We included that one, a self-efficacy scale, which was from the Personal Environment Education for Teachers test. The perceived relevance was really important, and of course autonomy. So that was actually a subscale of curriculum autonomy from the teacher autonomy scale. I've got all of the details for you if anybody wants to take any of this research further into their own and use any of those similar scales that we used. So we had a large data set, so over 200 participants, and we wanted to run a regression model to see what are the biggest factors, if you like. And we found implementation leadership was negatively influenced by perceived importance. Personal interest was a positive predictor of knowledge of sustainability, and perceived barriers negatively predict stress. Now, some of those things you probably would go, yeah, that makes sense, but it's good to have the data to represent that. So it would make sense that if I was a teacher and I had a personal interest, it would positively predict my knowledge. In other words, it would be that I would have increased knowledge of sustainability. And it would also be that if I perceived greater barriers, that I would have greater sort of stress. And the other way around, if I perceived less barriers, then I would have less stress. There's our sort of results table, which we've put into a publication, which is, I think we've had a revise and resubmit on it, but it's not published yet. And that's time. Yep, thank you. And on this slide, I just wanted to give you the fact that the overall model actually accounted for 60% of the variance in teachers' self-rated implementation. Self-efficacy and stress were the only significant unique predictors in the final model, and both positive predictors, and self-efficacy had the largest unique contribution to the model. So self-efficacy being a belief in our own abilities, that makes sense that a teacher needs that belief in their own ability, their belief to have that growth mindset, to actually learn what is needed to implement sustainability education into their curriculum area. Remember, here I'm not talking about teachers being science experts, because they would have this knowledge. I'm talking about a PE teacher or an English teacher, or maybe a teacher of music or language. and they can all implement sustainability education into their disciplines if they have the right knowledge. So here's our recommendations from our study, that we need a broader range of professional learning. We need to emphasise that sustainability for education requires skills for children to thrive and survive. Teachers need the knowledge and the confidence, in other words, the self-efficacy, and teachers need a framework of practice to create sustainable post-training. So they need to not only have some initial professional learning, but they need to also maintain that learning. And it takes a whole school approach. I whiz through this fairly quickly, but this was what we determined that their needs were around professional development. Most of them wanted a full-day workshop at the beginning of the school year, in school hours, and including content of sustainability knowledge. I think I would feel the same if I was a teacher. This booklet became, if you like, the handbook or the guidelines for sustainability education. So that was delivered free to all schools, and I'm offering it to you guys. I'm more than happy to share that if anybody can use it. We developed PowerPoints for the professional learning. We developed those little videos, the animations, and many of the, this one I'm showing you here was a large poster for classrooms. And we also developed a package of professional learning videos, which I had another one, but I think I'll say that. If anybody wants to have a copy of that, I can share that with you. Oh yeah, we had tip sheets. The list of deliverables was amazing, given that we were funded. So we could develop all these sorts of tip sheets. More than happy to share them. I've received approval from the Education Department to share them, which is great. This was the videos about peer-assisted learning, which I think we don't need to watch. I think you've got the general idea. And where to next? As I said, we've applied for another grant to move this forward and actually run the professional development that the teachers wanted using those materials, which I'm hopeful that we will get. The department has given us the heads up that we hopefully will be able to run that professional development. So as I said, just keep in touch, shoot me an email, and I can share any of those with you. Thank you. Thanks for your attention. Terry McCussey.
Okay, thank you so much, Dr. Elizabeth Edward from the University of Queensland for delivering the presentation about her research and the project. And after this, we have the Professor Konstantinos Ravanis from University of Patras. So Professor Konstantinos will accompany with the translator to delivering the speech about the presentation. For Professor Konstantinos Ravanis, please, time is yours.
Thank you very much. Apologize, I stay here to read my text, to be exact. And thank you very much, Elizabeth. If necessary, she makes me an introduction in French language. Okay. First of all, I would like to thank the university for the kind invitation. It's an opportunity to me to stay among you and experience your culture. And truly is a great honor to me. It's not my presentation, this presentation, it's another. Oh. No. Yes. Applications. Okay. I'm sorry. Yeah. That arrives. Used another presentation I made yesterday at the university. Yeah. Okay. Twice. Again. Thank you. Thank you very much.
Okay, so we're still waiting for the process of the presentation delivering from the officer. So this is the right. Okay, title. So
the constitution of science education as an autonomous scientific area with strong productive processes and at the level of theory, methodology and application was founded on three elements. First, the socially established need for the creation of better trained scientific and technological personnel in various countries of the world in very different phases of their economic development. Second, the maturation of scientific areas such as genetic epistemology, cognitive developmental and educational psychology, and ineffective reforms within the framework of traditional study, streams of teaching physics, chemistry, biology, etc. The above mentioned dimensions led to the search for the role and impact of children's everyday experiences on the way they approach the natural world and conceptualize natural sciences. The second dimension, namely the recognition in epistemology and psychology of the importance of students' spontaneous, naive representation of the phenomena and concepts studied in the natural sciences, has created a huge stream of research. Despite the fact that this investigation holds their origins from different theoretical backgrounds, they continue to reveal the patterns of thinking and reasoning of children at different stages of their development and schooling. These representations of children are well known in the international literature as misconceptions, ideas, alternative conceptions, perceptions, etc. I will adopt the term mental representation, which is considered more appropriate since it encapsulates extensive discussion of different areas of research on the fundamental question of learning, such as the structural and functional interactions with other entities of thought, and explanatory power, the cognitive dynamics they create, etc. When trying to move from the world of children's thinking to the issues of learning and teaching natural sciences, we find a number of important matters that need to be addressed. The cultural environment, the curriculum, the development of general mental skills, the scientific values. Among them, the recording of meta representation and the identification of the difficulties they create allows to illuminate the distance between scientific school knowledge and students' reasoning. This makes it possible to develop teaching strategies whose one of the main objectives is to overcome children's obstacles due to the mental representations and thus to transform them. Well-known such strategies are inquiry-based learning approach, 5E or 7E learning cycles, search, solve, create, and share method, and predict, observe, explain procedures. Nevertheless, the question that arises here is whether the approach of natural sciences constitutes a simple issue of just reorganizing or transforming children's mental representations, as the structural elements of the natural sciences have a very different constitution from personal constructs of thought. We know that the real discussion about the systematic approach is directly related to theories, models, principles, laws, concepts, etc. Consequently, the issue of effective teaching and learning of natural sciences hold three basic dimensions. The first one is related to students' thinking, the possibilities, the difficulties, and obstacles they face. The second dimension relates to the entities drawn from natural sciences as they are transformed in order to be suitable for the different levels of education. And the third dimension deals with the design and implementation of teaching procedures that allow students with different characteristics to approach knowledge from natural sciences as it is shaped for school conduct. In what follows, we will try to deal with the construction of models from natural sciences within the education field. Along this line, we will mainly highlight the dimension of a particular theoretical construction, that of precursor models. The term model is used in a simplistic way in everyday life, as well as in diverse sciences, denoting a series of entities with distinct qualitative characteristics. For example, in cognitive science, models are imperfect mental entities due to constraints caused by perceptual or cognitive factors. They have internal structure and possibilities of creating relation among them. In educational sciences, models are structures that define and describe interactions at the level of educational system, the school unit, or teaching and pedagogical relations. In natural sciences, in the context of epistemological ambiguity, quite often principles, theories, and laws are identified as models while in many cases the term is used to convey mathematical expression of a regularity, three-dimensional constructions, virtual or semantic representation of states, experimental arrangements, and etc. This polysemy, which is encountered within various science fields as well, was transferred to science education and actually enlarged as the field of study of science education converges on the one hand by the natural sciences and on the other by the social sciences. In addition, as science education became autonomous as a science, the concepts used within it were reconstructed and accurately related conceptual autonomy. Unfortunately, the inherited confusion about the concept of the model was not transferred to science education, but also began to acquire new features. Thus, for example, naive mental representation or scientific constructs of any kind that are transferred into teaching directly from reference sciences, physics, chemistry, are often characterized as models. So, by just talking about model, or better, school scientific models, we are not at all sure that we all mean the same entity. Hence our our goal is to try it in an inevitably semantic way to define the meaning and identity of the concept of model within science education file. Firstly, the human thought approach the natural sciences in education has two simultaneous entrances. The first relates to science itself as it is constituted and shaped for education, while the second to the natural world in which people have their first experience, which are extremely important. At the level of science, the formulation of integrated approach leads to the creation of theories which are large-scale construction that attempt to depict in an abstract and symbolic way structural and functional relationships of physical reality. A theory that is created and matures over time, approaches and interprets a wide range of phenomena that are amenable to common patterns of interpretation and are studied with given methodological tools. Typical examples of theories are relativity in physics or evolution in biology. The nature of range of theories impose specialized approaches that serve local solution in understanding and schematizing specific phenomena. It is precisely these approaches that are identified of models as models. The heart of scientific theory is not constituted by a set of axioms or laws, but by a set of models. Models include as the structural elements, hypothetical entities, and a set of interconnected concepts that serve to describe these entities. These models actually act as the origins of school scientific models, which are fundamental elements of school knowledge. Indeed, school knowledge along the path from preschool to secondary education develops at higher level of abstraction and gradually expands in terms of subject matter, remaining concentrated around basic models of the natural sciences. These models, such as, for example, geometrical optics or Bohr's atomic structure of matter, are basic entities for the foundation of natural sciences, and in order to be integrated into education, they undergo processes of transformation and adaptation, which are studied in the theories of pedagogical content knowledge and didactic transposition, or approaches that invoke the simplification of scientific knowledge. On the contrary, the constant immersion of human beings and social collective entities in the physical world creates a powerful and continuous source of stimuli that impose on thought and differentiate series of experience, images, and associations. The perceptual pathway of cognition is thus in constant simulation, and the addition and alternation of experiences raise questions and probe for possible answers. However, everyday contact with the natural world does not offer any criteria that allow for an organized and systematic investigation and sematization. Of course, everyday life is a constant source of specific challenges in many dimensions, covering a wide range that start from powerful phenomena of the wider human environment, such as earthquakes, weather, climatic change, volcanoes, fires, floods, etc., and extend to phenomena recognized during the use of conventional or digital technology at home or health. Gradually, the study of some of these phenomena is also chosen as a subject of work in school curricula after they have been allocated to different school and age levels on the basis of certain explicit or implicit criteria. During the study of the phenomena, an attempt is made to bring the students' thinking closer to scientific school knowledge. The basic premise of this attempt is the identification of the critical difficulties faced by students' thinking. Thus, along the path from reception of stimuli form of natural world to the approach of natural sciences, we inevitably pass through the mental representations we referred to the introduction. The distance of these entities of thought from scientific school knowledge underlines an important dimension of the effort to be made, and that is why the possibilities of specially designed teaching interventions at the level of the individual, the group, or the actual classroom are constantly being tested. Many years of research have shown that mental representations of concepts or phenomena of the natural science have certain characteristics. There are naive, implicit, local, non-conscious. That is why their transformation, although it seems to lead to new reasoning, often weakness over time, is easily destabilized in the face of new empirical data and merges without rules, with conventional school knowledge giving hybrid mental entities. However, a crucial question of the orientation of these efforts: what exactly is the knowledge to which we want to lead students' thinking? What is the direction of the desired changes in mental representations? Quite often this question is avoided or has no clear answer. In realistic directions, our interest confined in the knowledge included in school programs or textbooks, as well as just some changes in understanding and interpretation of natural phenomena, or encompass the development of skills that allow improvement in problem solving. Without underestimating any of the above mentioned points, a wide range of research streams often lead to a fundamental finding. School scientific knowledge is not constituted as a series of independently satisfactory mental representation or effective problem-solving skills, but as models whose structure and scope have some particular characteristics. These models, as described earlier, are transformed versions of scientific models through specialized process. We mentioned earlier two entrances of the approach, the human thought in natural sciences. When these entrances lead to in the field of education, we saw that from the point of view of natural experience, reasoning, and human everyday experience, we end up with a strong presence of mental representations in children's thinking. From the side of science itself, we meet through a path of adaptations of scientific knowledge, the models that are created for the purpose of learning and teaching natural science. The recognitions of these two dimensions in a rational perspective, it's not always self-evident, raises in a clear way to questions of the transition from mental representation to the mental constitution of models. The issue is familiar in the literature and in approaches characterized by the term modeling. It is fact that a range of different perspectives are recorded in the literature of epistemological, psychological, cognitive, and didactic parameters, create and often multiply complexity. We also well aware that the mental construction of a model is a long-term process that takes place gradually and assumes that students are actively involved in specially designed teaching intervention. Therefore, when we talk about transition, we mean more of a pathway and less for a final state. This is why it is particularly important to study the way students think along this process. This finding, however, must not be of a general character, referring to certain observed improvements or change, but to choose which contribute to the gradual formation of models in children's thinking. Along this perspective, the concept of precursor model was proposed, which in the context of the relevant research was developed and gave interesting results. The term precursor model, together with the work model, means it is a case of models that prepare for the elaboration of other models. Consequently, precursor models consist of a certain number of elements characteristic of the scholarly models towards which they strive. they necessarily have a reduced file of validity compared with scholarly models. Precursor models thus constitute didactic construction designed to help pupils access scholarly models. They are therefore precursors in regard to cognitive development. Therefore, as long as precursor models are elements compatible with certain features of school scientific models, it seems that they could be the appropriate entities to be grasped by students and interpose between scholar scientific models and meta representations. In the concept of precursor model, at the level of learning, we find established cognitive difficulties of children and elements of school models that we want students to understand. Thus, at the level of teaching, we offer the starting points and arrival points of the path that teachers and students have to follow in order to form in children's minds stable entities which have contents, structural and functional elements compatible with those of school models, and therefore creates solid condition to prepare students for the formation of real school models. In a rational approach within the context of science education, school scientific models are constructed with a structured process of transformations of scientific models. These models inevitably have distinct characteristics due to the different objects of study and the age of the children they concern. Indeed, the fundamental characteristics of a model for understanding a same electrical circuit or the interruption of a volcano are different. Similarly, a model for the dissolution of a solid into a liquid differs itself in case it is constructed for children in the early years of primary education or for students at the end of secondary education. Despite these differences, however, there are common elements which enable us to describe certain entities of thought as scientific models. In terms of structure and content, the normative entities such as laws or principle, the semantic relation in order to maintain systematic communication between models and phenomena, there is a need for precise correspondences among the symbolic elements of the model and the empirical elements of the phenomenon considered to the model. Regarding the functions of the models that are intended to be constituted in students' thinking during the learning processes, three levels are distinguished: the description, the explanation, and the prediction. The construction of a model in students' mind presupposes the ability to handle the necessary structural and factual elements of the models as they are depicted in the preceding semantic presentation. The differences in the levels of abstraction and the number of structural and functional characteristics of the models made it clear that the teaching processes which aim at the formation in students' minds are complex and require an instructional design with a wide range of time and specific provisions of curriculum. I'm afraid that I don't have time to present some examples of these approaches. And in the right text, I explain with examples the process of the precaution movement. Thank you very much.
Thank you so much, Professor Konstantinos Ravanis. I'm sorry for make interruption to you since the time is up. So thank you so much. So after this, we still have a couple of minutes for question and answer. I do apologize, but we need to make sure that we have give the same opportunity for the all speaker to have the discussion. So I would like to give my floor to the participant if there is any questions regarding the presentation from Dr. Elizabeth Edward and also Prof. Konstantinos Ravanis. You may raise your hand and the committee will come to you and give the microphone. So is there any questions from the participants? Or seems that you are understand and following the question. So I'm afraid that there is no questions. Yes, I think. Yes, maybe we can continue with the casual discussion during the lunch break. So thank you so much for Dr. Elizabeth and from Konstantinos. Please give applause for Dr. Edward and Professor Konstantinos for delivering the presentations. In the end of our keynote speaker session, I would like to give my biggest appreciation for all the speakers, Dr. Vishal, Dr. Achi, Bapak Fajrul, Dr. Edward, and Professor Konstantinos for delivering a very great, fruitful presentation to the audience. I hope that the participant get experience, hands-on experience from the expert, and perhaps that it will give the very great output for the publication. So thank you so much. Me as a moderator, I also do apologize for interrupting all the speakers, but the committee said to me that you need to make a good time management because the lunch break is come. So thank you so much. We hope that we can meet you again in the next agenda. So thank you so much. I close with our keynote speaker session. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. So for Dr. Edward and Professor Konstantinos, you may have back to the seat again.
Ladies and gentlemen, this is the end of keynote speaker session. Thank you very much for your attention. And after this is the time for lunch time. All the participants and the guests, you can have your lunch in the restaurant in this hotel. Thank you. So ladies and gentlemen, the restaurant and the lunch menu has been waiting for you. You can go to the restaurant now to have lunch. Thank you very much for your attention. See you in YC 2025.